Can you explain how to determine which values should be chosen for m and p when factoring a polynomial of the form ax squared plus bx plus c? So we're going to do the same thing with this problem that we did with the previous example. We want to rewrite ax squared plus bx plus c as ax squared plus mx, mx plus bx plus c. Okay, so we're going to be rewriting that middle term as two different terms. Now, before we start factoring this problem, we need to think about, do we have a greatest common factor? In the last example we didn't, but in this example we actually do have a GCF. So here, because my coefficients are 10, 35, and 30, all three of those numbers are divisible by 5. Now they all don't have the letter y, so the GCF here is just a number. So when we divide each of these coefficients by 5, we're left with 5 times 2y squared minus 7y plus 6. So now I can take the polynomial that's written inside those parentheses, and we can factor that out. We're not going to do anything else with the GCF of 5, but we're going to keep bringing it down to our final answer. So now we're going to factor what's inside those parentheses, just like we did the last example. So we're going to multiply 2 times 6, which is 12. So when I start to list my factors of 12, I realize that they need to add up to equal -7. Well, the only way for two numbers to add up to equal a negative number in this case would be for both of those numbers to be negative. Because if I want the factors of positive 12, I'm either going to need to multiply two positive numbers together or two negative numbers together. So I'm going to list the factors of positive 12 as -1 times -12, -2 times -6, and -3 times -4. The only pair of factors that give me a sum of -7 would be -3 and -4. So rewriting what's inside those parentheses, that would be 2y squared minus 3y minus 4y plus 6. But I still have that GCF of 5. But remember, we're not doing anything else with it, but we're just going to continue to bring it down. So now we're going to continue just like we did with the last example. We're going to factor by grouping. So if we look at these first two terms here, those first two terms have a greatest common factor of y. If I divide those first two terms by y, I would be left with 2y minus 3. Now, if I look at the last two terms, in these two terms, my GCF would be a 2. So if I divide both of those by positive 2, then I come up with -2y plus 3. But if you pause right here, notice that what's inside those parentheses is not exactly the same. We have 2y minus 3 and -2y plus 3. So we need to do a little bit of extra work here to get those to be the same. Well, if the only thing that's different are the two signs, then instead of taking a greatest common factor of positive 2, if I change that to a -2, then that actually changes the signs of everything inside those parentheses. -4 divided by -2 is positive 2. 6 divided by -2 would be a -3. So now we have what's inside those parentheses to be exactly the same. But remember, we still have that GCF of 5. But we're not doing anything else with it until we get to that final answer. It just keeps coming down. So now, Both sets of parentheses say the exact same thing, so I know that one of my factors is 2y minus 3. If I factor out of 2y minus 3 from that green group, I'm left with the variable y. If I factor 2y minus 3 out of that blue group, I'll be left with a negative 2. But don't forget that from the very beginning, we factored out a 5 for the greatest common factor. So in this instance, my answer would be 5 times 2y minus 3 times y minus 2.